Here we go. All right, we need to remember from last week that exponential functions and logarithmic functions are inverses. They undo each other. Now, they are inverse functions. Okay, now what does that mean about their graphs? What do we know about the graphs of inverse functions? They reflect over what? You bet. The graphs are always reflections over the line y equals x. The reflections are always graphs over the line y equals x. Now, I need you to think for a moment then. Okay, we have y is equal to log base b of x. Okay, the inverse is going to be an exponential function. And if you found the inverse would be y is equal to b to the x. Y is equal to b to the x. Now, if b is bigger than 1, that means that my b is going to be bigger than 1 here also. Just a comment. What kind of graph is that going to be? B to the x, b is bigger than 1. Exponential growth. Very nice. Okay, now we should understand then that the graph at 0, I'm at A, well that's going to be at 1. My graph for exponential growth is going to look something like this. Okay, where is my asymptote? Where's my asymptote? Y equals 0. Okay, now we need to think about the line y equals x. Well, my line of y equals x is going to look something like this. Now, I realize that my log function, thank you, my log function, the inverse, is going to be a reflection over that line of y equals x. Think about your asymptote first. My asymptote for my exponential function was y equals 0, the x-axis. Where will my asymptote now be for my log function? Beautiful. Excuse me, did I say that wrong? I said the x-axis, didn't I? The exponential function is the x-axis, so my logarithmic function will be the y-axis. Absolutely. If I flip over that line of y equals x, I'm going to be at x is equal to 0 for the asymptote. And we should also realize that what do we do for inverses? How do we find the inverse? We switch the x and the y, right? So if it was y equals 0, now it's going to be x equals 0 because we switched the x and the y. That should make sense to us on 2 levels. Now, I should also understand then that if I went up 1 here, I'm going to be to the right 1 here. And if I'm looking for a reflection, my graph is going to look something like this. So my logarithmic function, the parent function for my logarithmic function is going to be to the right of the y-axis. Parent function. It's going to be to the right of the y-axis. My asymptote is now x equals 0. What is the domain? What is my domain of that graph? My green logarithmic graph. X is greater than 0. I'm always to the right of that line at 0, right? X is greater than 0. I can never take the log of a negative number. That's illegal. I can never take the log of a negative number. And what about my range? Where are my y values? All real numbers. I have y's that are negative. I have y's that are positive. All real numbers. Okay, now let's take a look over here. Thinking about this, log base b of x, we know that the inverse is going to be y is equal to b to the x. It was logarithmic, its inverse will be exponential. My b is going to be between 0 and 1. For my graph of y is equal to b to the x, what do I know about that graph if my b is between 0 and 1? It's exponential decay, absolutely. Exponential decay. So in this case, my a value is 1, so I'm always up at a. And I know for exponential decay, it's going to come down and to the right. And once again, we realize that my asymptote is that x-axis, the line of y equals 0. Now, we know that inverses are reflections over the line of y equals x. So if I put that line of y equals x into my graph, what is the first thing that I should know? Beautiful. My asymptote was y equals 0, the x-axis, so my asymptote is now going to be x equal to 0 on the y-axis. All right, so my asymptote is x equal to 0. Then it's a reflection. So these get a little bit tricky to draw. If I am going here, that means I'm going here. And I am going here. Notice that when my b is bigger than 1, it goes down and approaches that y-axis. When my b is between 0 and 1, it goes up towards positive infinity as it approaches that y-axis. All right, what is my domain? What is my domain? X is greater than 0. Absolutely. X is greater than 0. I can never take the log of a negative number. Basic rule about logs, I can never take the log of a negative number. All right. What is my range, Levi? All real numbers. Every log function has a range of all real numbers. All right. Let's see how they are to graph when we're not thinking about the fact that they are inverses. Yes. I know that the inverse of a log function is an exponential function. If I, let's show that. If I had y is equal to log base b of x, all right, what do I do to find the inverse? Switch the x and the y. So x is equal to log base b of y. Remember that if it starts out as a log, its inverse has to be exponential. If it starts as a log, its inverse has to have x in the exponent. If it starts out an exponential where x is in the exponent, its inverse has to be a log. So that means that my base is b. It's going to scoop up that x, and it's equal to what's inside, which is y. So there's my inverse. Okay? If it starts out as a log, its inverse has to have x in the exponent. It has to be exponential. Okay? Fantastic question. Anything else? All right, now let's take a look at how to graph these. And this is going to be a little bit different than anything you've ever graphed. Okay, so we're looking at this parent function right now of log base 2 of x. Now, I need you to remember what you are doing. When you are finding a logarithm, you are finding an exponent. Okay, we're going to use that idea of our definition of a logarithm to help us graph these in a very quick and efficient way. We shouldn't need a calculator to graph these because we're going to graph it in a way that's going to make them nice. Now, what base am I in? Base 2. Okay, when I'm finding a logarithm, I'm finding an exponent. Okay, so here's what's going to happen. I'm going to build myself an XY table. And typically, which numbers do I typically use for x? -1, 0, and 1, or I could even say -2, -1, 0, 1, and 2, right? Those, if I were going with 5 values, those are the 5 I would choose, okay? However, I realize that when I'm finding a logarithm, I'm finding an exponent. I am going to make it so that my -2, my -1, my 0, 1, and 2 are the exponents I am finding. Now, this is how it's going to look. I realize that I am in base of 2. So I'm going to make the -2, the -1, 0, 1, and 2 my exponents of that base of 2. So for my x's, I'm going to do 2 to the -2, 2 to the -1, 2 to the 0, 2 to the first, and 2 squared. Whenever I'm graphing a log, I'm going to always have the base to those exponents. And you'll see why in a minute. It makes it really, really nice. Now, if I plug this in, that means I have log base 2 of 2 to the -2. Anybody got a thought? It's -2 because when the base of my log matches the base of my exponent, they're inverses and they undo each other. My exponent is 2. When I'm finding a logarithm, I'm finding an exponent. So log base 2 of 2 to the -1. Base of my log matches the base of my exponent. They cancel, and my exponent is -1. Now, log base 2 of 2 to the 0. Base of my log matches the base of my exponent. My exponent is 0. Log base 2 of 2 to the first is 1. Log base 2 of 2 squared is 2. I want to see this on your paper every time. I don't want any magic. I want to see that. I want to know that we understand what is happening there. Now, the tricky part is that you've never had to go back, though, and look at this. In my x column, what is 2 squared? 4. So that means that when x is 4, my y is 2. What is 2 to the first? 2. So that means when my x is 2, my y is 1. What's 2 to the 0? 1. When my x is 1, my y is 0. What's 2 to the -1? A half. Yep, 1/2. So when my x is a half, my y is -1. And then what's 2 to the -2? 1/4, right? 1 over 2 squared, so that's 1/4. So when my x is a fourth, I'm at -2. Now, is there anything else I should be putting on this graph? Where is my asymptote? X equals 0. That y-axis for my parent function of any log graph is going to be at x equals 0. And notice this graph approaches that y-axis as it approaches -infinity, and then it goes up and to the right. All right, so a couple things we can fill in here. My asymptote is x equals 0. All right, Samantha Elm, what is my domain? X is greater than 0, and what about my range? All real numbers. Great. Any questions with that one? Any questions with that one? All right, let's go to another one. All right, we're going to graph y is equal to log base 2/3 of x. My parent function, y is equal to log base 2/3 of x. And I'm going to start out by making an xy table. All right, what am I going to put in for my x's? Does anybody have a thought? Raise your hand. What am I going to put in there for my x's? Matt? All right, we're going to have 2/3 to the -2. We're going to have 2/3 to the -1. 2/3 raised to the 0. 2/3 raised to the first. And 2/3 raised to the second. The xy table looks very, very different. Now, evaluate that. Find those values. Find your points on the graph. If you're struggling, I will come around and give you a hand. when you are graphing these on the next quiz or test on Thursday, when you're graphing these on the next quiz or test on Thursday, these will definitely be on the no calculator portion. You will not have a calculator for these. I want to know that we can graph them, not that our machine can. All right. All right. So when I plug in for y, I have log base 2/3 of 2/3 to the negative 2, which is what? Leslie, what did you get for that? Base of my log matches the base of my exponent. They cancel, so negative 2. Then I have log base 2/3 of 2/3 to the negative 1. I'm finding my exponent. My exponent's negative 1. Log base 2/3 of 2/3 to the 0. Finding my exponent is 0. The base of my log matches the base of the exponent. They're inverses, they undo each other. Log base 2/3 of 2/3 to the first. My exponent's 1. And log base 2/3 of 2/3 squared. My exponent is 2. All right, now I'm not ready to graph yet. I need to go back and find my x's. And I always usually go from the bottom to the top on this because the bottom ones are nicer than the top ones. All right, Zach, what's 2/3 squared? 4 9s. I love it. How about 2/3 to the first? 2/3. What about 2/3 to the 0? 1. What about 2/3 to the negative 1? You bet. The reciprocal, so 3/2. And what about 2/3 to the negative 2? 9/4. It's going to be the reciprocal of 2/3 squared. So it's easy once you work backwards. All right. So 9/4. That's going to be 2 1/4. So at 2 1/4, I am down at negative 2. 3/2 at 1 1/2, I'm down at negative 1. 1, I'm at 0. At 2/3, I'm up at 1. At 4 9ths, a little bit short of a half, I am up at 2. All right, what else do I need to add to this graph, Alex V? Where is my asymptote for the parent function of a log graph? All right, x equal to 0, I'm going to make it on that y-axis. All right, and my graph approaches that y-axis, bless you, as it approaches positive infinity there, and it goes down and to the right from there. All right, my asymptote then is x equal to 0. Karina, what's my domain? X is greater than 0. And what about my range? All real numbers. Beautiful. Any questions with that? Any questions with that? All right, now, need to tackle one more thing here yet, is what happens when we translate it. What happens when we are given a situation like log base b of the quantity of x minus h plus k. All right, what is going on with this h value? You bet. That's going to shift it left and right. It's going to slide it left and right. And what about that K value, Connor G? Moves it up and down. All right, now I want to see in every single case the parent function and then the translation. So y is equal to log base 3 of the quantity of x minus 2 plus 4. All right, so to get started here,
what's the base?
3. Yeah. All right, what is my parent function here? And you've got to put these on the graph. Brendan, what's my parent function? Y is equal to log base 3 of x. It's always everything through that x. Take my parent function, it's going to be everything through that x. So y is equal to log base 3 of x. All right, go ahead, make that xy table and graph that parent function. Make that xy table, graph that parent function. Need help, let me know. All right, help me out with the XY table here. As we're finishing up there. Kendra, can you help me out with the XY table? What am I going to do first?
Your x's.
Yep.
3 to the negative 2.
3 to the negative 2.
3 to the negative 1.
Yep.
3 to the 0.
Yep.
3 to the first. And 3 squared.
Beautiful. All right. Now for my y's, how do I find my y values?
Log base 3 of 3 to the negative 2 power equals 8.
Beautiful. My base of my log branch is the base of my exponent, so they cancel. When I'm finding a logarithm, I'm finding an exponent. Yep.
Log base 3 of 3 to the negative 1 equals negative 1.
Good.
Log base 3 of 3 to the 0 equals 0.
Perfect.
Log base 3 of 3 to the first equals 1. And log base 3 of 3 squared equals 2.
All right. Now, am I ready to graph? All right, Brooke, what do I have to do to get ready to graph yet?
You just switch the x's.
Okay. Got to finish up cleaning up my x's.
3 squared is 9.
3 squared is 9. 3 to the first is 3. 3, anything to the 0 is 1. 3 to the negative 1 is 1/3. What? and 3 to the negative 2 is 1/9. Good. So at 1/9, I'm at negative 2. 1/3, I'm at negative 1. 1, 0. 3, 1. And 9, 2. All right, what else needs to go onto this graph, Kaylee? Perfect. Where is it? X equals 0. My y-axis is going to be that asymptote for every parent function of a log graph. So my graph is going to go down towards negative infinity as it approaches the y-axis. Oh, I even wrote it wrong. I'm sorry. X equal to 0, not y equal to 0. And then it's going to go up and to the right. Perfect. All right, now on this graph, what else is going to happen to this graph, Brody? It's going to go right to and up 4. Move your asymptote first. Right 2, up 4. The up 4 doesn't do anything for your asymptote, but the right 2 sure does. All right, so right 2 takes my asymptote to x equal to 2, and then I'm going to move every single point right 2 and up 4. All right, so right 2, up 4, right 2, up 4, right 2, up 4, right 2, up 4, right 2, up 4. There it is, translated, right 2 and up 4, never crossing over that vertical line at x equal to 2. All right, Daria, what's my asymptote?
X equals 2.
X equals 2. What about my domain?
X is greater than 2.
Beautiful. To the right of that line at 2, x is greater than 2. And what about my range?
All real numbers.
All real numbers. Perfect. Any questions about that? Any questions? All right.